McKelvin. I work for Platform 45 as a Rails developer, and today I'm going to talk about a subject I'm quite passionate about. It's just object-oriented principles and designing clean code, which ties in very well with the previous talk Matthew just gave about the art of Ruby. And I think this is going to be just an application of that art. So my opening premise for this is that most conditionals that we deal with can be replaced by polymorphism. So we started off in the realm of procedural, the basics of the world that eventually led into structured procedural languages. And in that, we were able to get rid of goto. And I don't think anyone's really missed it. Although, it was pointed out to me that you can compile Ruby to support goto. But that's if you really want to make your team hate you. But the way that I see this now is that as you go from these procedural languages into object-oriented programming, you can get rid of quite a lot of ifs. Not all. There are places where you need to compare primitives, is 7 greater than 3 or not. You're not going to get away from that. But where you've got, there are a few code smells. So where you've got differing behavior that occurs based on variable state, if you're checking the same thing multiple times, and especially if you've got case and switch statements in your code, those are usually pretty clear signs that the conditional shouldn't be there and polymorphism should be there in its place. So to give an example, I've coded up a few little examples, and it's going to be, this first one is deliberately contrived just to get the pace going. After this, I've got a couple more examples that are more in depth that I think will flesh out the problem more. So in this case, we've got a bird, and depending on a variable that we pass into its constructor, we can change its behavior. Now, the first thing is, don't we already have a type system in Ruby? So as soon as you see something like that, it's begging to go into your domain. So what you can do to this is, just instead of having this going on variable switching, we can create a separate class, say African swallow, that defines a method called speed that results in 200, and a European. That does 300. So the code that's still in there above is still there. If I were to run this, and I'm just running it inside Vim, I get the value 200 coming out based on a variable that I pushed in. But if I change that out to use the same, the new class, and just clear that. If I run that again, we still get 200. So that's just the basics of it. We've now taken what was a magic string and pushed it up into our domain. We've got a name for it in our system. This isn't something that's just randomly sitting in our code base. So that's the first example that I've got. Now, I want to go into something that's a bit more in depth. Let's take this mathematical sum, arithmetic, and we want to model this as a tree. So we'll probably build it into a tree structure similar to this, where we've got a set of nodes. The node has references to other nodes, and we are able to evaluate this and get to a result. Parallel to that, we also want to be able to get a string representation of this tree that would print out basically the human representation of it, not the result. So how do we go about this? Well, then I've got an example. So, okay, so this is a pretty brute force way of doing it, and as you'll see, there are quite a lot of conditions in there that are pretty much littered about, but let's go through it. In the initialize, we're passing in what our operator is, a value if we want to give it a number, so we will be saying 1 plus then 2 times 3 each of our nodes, they'll have a value. But then the node also has a left and right child on it. So if we then look in the evaluate, what we then take is the result of the left node and right node, and we add them together, or multiply them. Or we might check if it's a null, which is a pretty clear sign that we've got quite a lot of mixed behavior in one place. Same applies then on the toString, where we've got pretty much the same conditional. We're checking the same conditions. Remember, that was a case that I mentioned at the beginning. Below here, I've just got a little example of then using these nodes, and just to prove that it works, I can run that, and I get the node.evaluate gets me my answer, and toString then prints it out as prints the nodes out. But we can do a heck of a lot better than this. So let's see. The first thing that I want to identify in this is we've got mixed dependencies. In the case of the multiplication and addition node, we care about the operator, the left and the right node, but we don't care about a value. So we're holding a null there for no reason. In the case of a value node, we've got the value and we don't have anything else, and we're holding nulls. So if you looked in the conditions that we had in the code, we've got a null check right there. We can get away from this by taking these concepts out of this class and breaking them apart into separate classes and giving them names in our domain. So the first thing I'm going to do is break out the value node. Take the value behavior out of this and implement it in a separate class. Now the trick of this is to expose the same public interface as what we have in Node at the moment. So let's create a class called a value node. And the initialize just takes a value. Assigns it into an instance. Evaluate over here then just takes the same implementation as that conditional above. And toString would do the same thing as the implementation above. We can then change out these nodes that we've got below here, which had all of these nulls that we're passing into it, and change these to value node. And instead of passing nulls, here we can just take those out. And if I were to run this now, let's just clear this out. Run it again, we've got the same behavior. But now we've taken this concept of a value out of this class that was a God class and put it into a class of its own. We've got behavior that's completely isolated and doesn't care about additional subtraction or any other operations. So we're going to do the same now with the addition node that we've got down here. So let's create a new class, addition node. Initialize. If we looked at the dependencies that we had here, in the case of addition, we cared about the operator, the left and the right. Well, now the operator has come out to a domain concept, so we don't actually care about that. All we need to give it is the left and the right node. To implement the evaluate on that, it would just take, basically, if I go up here, the same evaluate and the same toString as we had up here. And now we can change out our addition node down here to, firstly, we said we've taken the operator away from being just a state of a string and put it into our domain, so we don't need that. We're not passing it a null anymore. Look, it doesn't care about the value, so we don't need that. All we need is the left and the right node. Notice that in this addition node, we haven't got us any conditional. We're not doing a null check on the operator or anything like that, but we still have the same behavior. If I take this out, I still get the same result. The same thing then we can do to the multiply node, which is pretty quick to do. Evaluate is there, and there. Now we can just replace that node there with a multiply node. Should have called it a multiplication node. And the same thing applies. We don't need the operator, and we don't need the value. If I run that again, we still get the same result. So right now, this whole shamble that was above here is no longer needed. This node class can come out. So what have we got here? We've now got a system with, well, an entire class here without any ifs, or an entire code base without a single conditional. But what's happened to them? Well, we've brought out the main concept. We've got the concept of addition, multiplication, and values now at the domain level. And as we're constructing our objects, we're declaring our intent. Now, this is where conditionals normally end up in factories, because I can now take any source, any object that I can create, I could, that can parse that text expression, could create this tree and just reapply these nodes of the same code. But there's another advantage to this, that before, with that initial structure, if I wanted to add, let's say, a division operator, or what if I wanted to add an operator that only required a single node, it's a unary operation like a trigonometry sine, I would have had to monkey patch this code pretty badly. In the case of, in the structure we have now, it's easily extensible. If this was packaged up into a gem and I wanted to add the ability to get sine, I'm actually just going to go here. We could create a sine node that only takes one node. You can evaluate that to now Ruby's math.sine is a bit weird. That you have to node dot, it takes radians, so evaluate math 5180. And the toString could just be and now I've got sine available. But it's a completely new class. I haven't monkey patched anything. I haven't had to change existing code. And this is the application of the open flows principle of solid. I've got a class that I don't need to touch. I can extend it, but I don't need to modify it. Okay, so just to drive the point home a bit further, I think this is a pretty practical example of applying inheritance to polymorphism. But we can still do a level of inheritance here, because we've got two pieces here. This initializer here on the multiplication node and on the additional node are identical. So we've got the same concept here of a binary operator. So let's give it a name. Binary operator node. The initializer on that can just be, that just takes the initializer, and this can be treated as an abstract class. We take this initializer out of both of these and just inherit binary op node. and then we've reduced our duplication of it. Okay, so that was my second example of it. Next example I just want to give is around something that's pretty common in our apps is logging. In certain cases, you'll want to have detailed logs. In some cases, you just want to have a summary of a log. So I've got a logger class here that I initialize, takes a Boolean operator if one verbose logging or not. And if it's verbose, if verbose is enabled, then it will write it out when I call it verbose, otherwise it will just leave it blank. So if I were to run this, just go look at the code again. I get hello Rubyfuza, but I haven't passed the verbose option, the -v option, so it ignores the second line. If I add the -v just so you can see, it then gives you both lines of output. But we can do a lot better than this. We've got, again, polymorphic behavior based on switching on variable state. So let's change this up a bit. Let's rename this from logger to be just a standard logger. So in this case, the idea is that when you give it a verbose log, on a standard logger, it just does nothing. It's no one. So we can take that out, do nothing, which means we don't need that dependency on term ANSI color anymore. And when you want verbose login, we can just override that behavior. And we give it a name verbose logger, which is easy to understand. So the other thing we can do there is we will no longer need that initializer, so that simplifies it. We'll just inherit from standard logger here, and we will override the behavior of the verbose method to actually okay, so if we wanted to now use this, instead of instantiating a new logger based on the argument here, we would change this out. Instead of passing the Boolean to the initializer, we now just change which logger we're instantiating. So if argv.include -v, we will get a verbose logger.new, otherwise we'll get a standard logger. And assuming I haven't done anything stupid, it should still work. But we've now taken something that was, again, it was a switch of behavior based on variable state, and we've pulled it up to our domain level. I think that this reads a heck of a lot more cleanly than the code initially was. We've got rid of conditionals, which means code is easier to test. We've got one path through it. We had a talk yesterday talking about pure functions. Now, okay, granted some of these aren't pure functions, they do have fewer paths through them, which is the result that we were talking about there, which makes it a heck of a lot easier to test. So that's my examples on applying some basic object-oriented programming practices. I mean, these have been around for donkey's years, for longer than I remember, for longer than I've been programming. But applying these lessons that have been taught from over the last 30, 40 years, we can really get into a code base that's really easy to read and really clean. We become that artist that we were talking about. So that's pretty much all I got. Can we have any questions? Gabriel.
How would you programmatically select the multiplication of parentheses? So then you would state coding or hard coding total multiplication, it's creating multiplication. How would you programmatically without avoiding state?
What?
And avoiding statements at the same time.
Okay, that's where the question I asked actually at the time that I was talking about is what happened to the if statement there? Is it goes into the code that will instantiate this. So if you've got a parser for an expression, that's where your conditions will be. But you've got to, by taking it up to the parser, to a parser of that expression, your code for the actual implementation can be free of the conditions and can be very focused. So when you're going with this kind of design, you'll often have a lot of factories, which will take some argument, some value, some state, and determine which version of the object to create. Any other questions? Come on.
Will you send out a list of all the plugins you use?
If you must. My Polymorphic is on GitHub. I'm McKelvin on Twitter, on GitHub. Just find me there. Some.
What's that? What would you do in the base class if you were right?
Okay, so what I've done on it depends on the code, right? But you can implement a method on your base class that just raises an error, not implemented error or something like that. That just gives you a sign saying go and implement this method in subclasses of this class, which has worked pretty well because if you get to a stack trace on that, it pretty much tells you where to go back to. I think that's the option that I've really gone for in the past. So,
You're getting rid of conditionals, but does this make scoping harder?
scoping. Scope. If anything, it makes it easier because we took dependencies of the responsibilities of that class apart, where we had the value and we had all of the knowledge about nodes in the same class initially. We could take those apart. So I would say it gets a lot simpler. Keeping track of what we have in private state in our class. Does that answer? Any other questions?
Is there any other good resources where people can look for this? Because I know there's one you actually...
Okay, so everyone's been talking about Sandy Metz's book, Practical Object-Oriented Design in Ruby. I confess I haven't actually read it yet. It's on my list. It has been for the last 6 months. But apparently that's great for this kind of thing. I saw this example first done by Mishko Hevery from Google in one of his clean code talks. It's done in Java, but it's a really good resource on this kind of style of programming as well. But also the books that we've generally been talking about, Clean Code, Code Complete, they all lead you down this path at some level. Any other questions? All right, thank you.
No come electro por la vida.